Hello, ladies and gentlemen. We're going to do the Chapter 11 and 12 review packet to get you ready for the test that we have next week, or depending how long you waited, this week. The packet, the first page is the surface area and the volume questions that you'll be responsible for. Keep in mind you'll be given the formulas, but you will need to know how to apply them. Problem 1 is a square pyramid. We need to find the volume. It has a base edge of 9 centimeters and a height of 14. I'm told that the volume of this kind of thing is V equals 1/3 capital B times H. Well, capital B means the area of the base. The area of the base is, all right, it's a square pyramid, 9 times 9. So volume equals 1/3, and 14 was given to us in the actual formula. I'm going to go straight to my calculator and do 1 divided by 3 times 9 times 9 times 14 gives me 378. My volume is 378. It's volume, so it's cubic centimeters. Make certain that we watch the units for these. Find the volume. This time I've got a cone. I know that the volume of my cone given to me is 1/3 pi r squared. The area of the base is pi r squared times the height. It is important that when we're finding the height, we're using the perpendicular measure. So my radius is 9, 1/3 pi 9 squared times 18. I'm just going to rearrange this before I go to my calculator. So 9, and I'm going to simplify a little bit. 1/3 times 81 times 18, and I'm not going to forget my pi. Now, the packet didn't tell us what our units were to be, and I told my classes that we were going to do this to the nearest 100th. So I'm going to come to my calculator, and I'm going to say 1 divided by 3 times 81 times 18. So that's 486. So if you were doing it in terms of pi, your answer would be 486 pi. But like I said, I told my classes that we were doing this in terms of pi. So I'm going to take my answer and multiply that by pi, and that tells me that my answer is 1,526.81. And I know that once I put in pi, it's an approximation. So 1,526.81, it's a volume, so it's cubic centimeters. Number 3, find the surface area. I'm told that the surface area equals 4 pi r squared. So surface area equals 4 pi r squared. My radius is 7, so 4 times pi, 7 squared is 49. I'm going to go straight to my calculator and say 4 times 49. If you were doing this in terms of pi, you would end up with 196 pi inches squared. We'll talk about that in a second. But I told my classes we were doing this rounded to the nearest 100th. So I'm going to take the answer and multiply it by pi. Use my pi button to get the most accurate answer, 615.75. 615.75 is my surface area. I've got square inches. Surface area is an area. All areas are squared, all volumes are cubed. All right, now I've got these composite shapes. So I need to find the volume of each composite figure. So for number 4, I need to find the volume of the cylinder on top and add to that the area, no, the volume of the cylinder on the bottom. So here's my volume formula. We'll use this. So I'm going to say the volume of the top cylinder is pi r squared. R is 2, so 2 squared. And my height is also 2. My volume of my bottom cylinder is pi r squared. R is 3, so 3 squared, and my height is 3. I'm going to take to find the full volume equals the volume of the top plus the volume of the bottom. So let's see, my volume of the top 2 squared is 4. 4 times 2 is 8, so I have 8 pi. The volume of the bottom, so I'm going to do 3 squared is 9. 9 times 3 is 27, so plus 27 pi. I'm going to say 8 plus 27 is 37 pi, and I'm going to go to my calculator with that number. The longer I can wait to do any rounding, the more accurate my answer is going to be. So I go to my calculator and I say 37 times pi, and my answer rounded to the nearest, okay, so this is 109.956. Well, 109.956. Now the directions for this one, and anytime your directions on the papers, that trumps whatever I've told you orally or if I say for the whole thing. So let's see. I'm going to move this down and say I need to consider my rounding. So I look at this number and that tells me what to do here. So I'm going to say that 5 is big enough to change that 9. So I'm going to round up. So my volume ends up being 110, but I write 0.0 because that says, hey, I considered what was going on here. My units are cubic feet. My volume is always cubic, so there's my final answer for that one. All right. Now, for this one, I have composite figures of a cylinder. So I'm going to find the, let's see, the volume of the entire thing is going to be the volume of the cylinder plus the volume of the rectangular prism. So the volume of the cylinder is, well, we've got the formula down here, and so I'm going to say pi r squared h. So pi r squared, 2 squared, times h is 4. So my volume is 2 squared is 4, 4 times 4 is 16. So the volume of the cylinder is 16 pi. The rectangular prism is length times width times height. So I've got 10 times 5 times 3. 10 times 5 is 50. 50 times 3 equals 150. So I'm going to go to my calculator and I'm going to type in 16 pi plus 150. 16 pi plus 150 gives me 200.265. My directions are round to the nearest tenth, so 200.3. I've got a pi in there, I rounded. This is approximately. And my units are meters. I'm finding volume, so it's meters cubic meters. All right, moving on to chapter 12. Find each indicated measure round to the nearest hundredth when necessary. I need to find the measure of arc CDE. So CDE, and that could have been called arc CE. So let's see, I know that this angle right here is 90, which means that this part of the arc is 90. And I need to know what this part of the arc is. Well, this angle is 40, which means this angle is 40. Central angles and central arcs share the same measure. So if this is 40 degrees, then this is 40 degrees. And the measure of CDE is 90 plus 40, or 130 degrees. I need to find the measure of arc BCD. I'm going to erase this, make it a little bit easier for us to say BCD is this arc right here. All right, well, the one thing that I see is that F is the center of my circle, and I have this. Well, that means that this entire arc right here is 180, and I know that this arc right here is 40. So in that case, the blue arc is going to be 180 minus 40, which gives me 140 degrees. Problem number 7, we need to find EF. So the first thing that I'm going to do is, and I'm going to draw in this radius, and I realize that that radius is the exact same thing as this radius. So 9 plus 8 is 17, which means that this radius right here is 17. I'm going to take a second and trace this and move it out here and make it a little bit, oh, I hate when it gets all distorted. All right, that'll be good enough. I know that this is a right angle. I know that this is 17, and I know that this is 8. I don't see anything. There's no special right triangle that's popping out at me. So I'm going to label this as X. And EF is going to be 2X, right? So if this is X, I know, based on one of the theorems that we learned, that if the radius crosses a chord at a 90-degree angle, that it bisects that chord. Okay, so I'm going to say X squared plus 8 squared equals 17 squared. I'm going to go to my calculator because I don't know what 17 squared is. 17 squared is 289. Of course I knew that. What the heck was I thinking? 289. I'm going to subtract 64 from both sides, and that gives me 225. I recognize that as being a perfect square, and yet I don't trust myself. So I'm going to come over here and say 225. Nope. I'm going to say the square root of 225, and that's 15. That's what I thought, but this was a better safe than sorry. So X is 15. If X is 15 and EF is 2 times X, then we've got 2 times 15. So EF is 30. I don't have any units, so I don't have to write any in. All right, number 8, we need to find JK. JK is this segment right here. This segment is tangent to the circle, and JK is tangent to the circle. HK is tangent to the circle. They're both tangent, and they're both tangent from the same external point K, which means that I can say this is congruent to that. Because that's congruent to that, we need to say 2x plus 5 equals 3x minus 2. I identify where I have the most x's and move everything to that side. I end up with 5 equals x minus 2 and x equals 7. The question doesn't ask me what 7 is. The question asks me what JK is. So I'm going to plug 7 into there. So 2 times 7 plus 5. 2 times 7 is 14 plus 5 equals 19. Again, I'm not given units, so JK equals 19. We need to find the area of sector CDE. A sector is 2 radii and the intercepted arc. It's the area bounded by the 2 radii and the intercepted arc. The area of a sector is pi r squared times m over 360. Yes, you do need to have that memorized. So pi times 6 squared times 70 over 360. 6 squared is 36. I recognize that 36 divides into 360 10 times. So I'm going to cross that out and say this. I recognize that 70 divided by 10 is 7. So I'm going to do that division. So my final answer is 7 pi centimeters. And this is an area, so it's squared. We did talk about having these answers done in terms or rounded to the nearest hundredth. So I'm going to go to my calculator and say 7 times pi gives me 21.9911. So 21.9911. I'm rounding to the nearest hundredths. I looked at the third thing, and that tells me what to do. So my volume, excuse me, the area of my sector is going to be 21.99 centimeters squared, approximately. Number 10, find the segment of circle R, keeping in mind that a segment is the sector minus the triangle. So I'm going to take the area of my segment equals the area of my sector, that's the pizza-shaped wedge, and I'm going to subtract out the area of the triangle. The area of the sector is pi r squared m over 360, and the area of the triangle is 1/2 base times height. You guys see this coming. You know this is going to be a pain in the neck. You know I'm going to ask you 1.5 million questions, and you justify everything. Pi r squared. R is 8, so 8 squared is 64, and we have m over 360. So I'm going to say 60 over 360. And I'm going to erase this in a second. I'm going to tell you that I look at 360 and I say 60 divided by 360 is 6. So I'm going to change this fraction to be 1/6. And honestly, I'm trying to reduce the amount of visual clutter. So I'm going to leave that the way it is. No, I'm not. I'm going to say 6 does not go evenly into 64, but I can reduce this. Both of these numbers are divisible by 2, so I'm going to say that this becomes 32 over 3. So I'm actually going to, in the interest of space, I'm going to change this to 32 over 3. Okay, I'm actually going to come over here and say pi times 8 squared over, or times 60 over 360. And I'm just going to leave that there just in case anyone needs to know where that came from. All of this simplifies to be that. We're going to look at the area of the triangle. And I'm going to come over here and trace the triangle. And I'm going to enlarge the triangle. And we know that this is 8. If this arc measures 60, then this angle measures 60. I know that this side is 8. I also know that this side is 8. If both of those sides are 8, then I know that this triangle is an equilateral triangle. And if I know that this triangle is an no, that's not what I meant to say. If I know that these two sides are 8, I know that this is an isosceles triangle. And if I know this is an isosceles triangle, I know that my base angles are congruent. So I can say x plus 360 equals, oh my goodness, x plus 60 equals 180. So I'm going to say 2x plus 60 equals 180. I'm going to subtract 60 from both sides. 2x equals 120, which means that each one of these x's is 60 degrees. Great. Now we have proven to ourselves that this is an equilateral triangle, and I know that this side over here is 8. I need to drop an altitude. I'm going to go ahead and, it's weird, there's no right side for this. I guess we'll come this way. So I'm going to draw in this angle, or this altitude. I need to find this height. I know that this is 60, I know that this is 90, and if this is 60 and this is 90, 60 plus 90 plus, well, if we're looking for this, we'll call it x for a second, equals 180. Well, 60 and 90 is 150, which means x is 30, which means that what we have right here is a 30, 60, 90 triangle. If I know this is a 30, 60, 90 triangle and my hypotenuse is 8, then I know that my short side is 4. And if I know my short side is 4, I know that my long leg is 4 times the square root of 3. So I'm going to come over to my area of my triangle, and I'm going to say my base is 8. So 1/2 times 8, and my height is 4 times the square root of 3. We were finding that right there. So 4 times the square root of 3. All right, I'm going to bring down 32 pi over 3. 1/2 times 8. 1/2 times 8 is 4. So now I have 4 times 4 times the square root of 3. When I multiply anything involving a radical, anything outside the radical stays on the outside of the radical. Anything inside the radical stays inside the radical. So 4 times 4, those are both outside the radical. 4 times 4 is 16. And then 3 is inside the radical, so it stays inside. I have got a nice, concise thing that I can take to my calculator. And because I'm doing it in one step and everything is as simplified as it can be, I'm going to get the most accurate answer. So I'm going to take 32 times pi, and I'm going to divide that by 3. I'm going to subtract 16 times the square root of 3, and that gives me 5.7975. 5.7975. So this is the area of my segment, and our direction said, in absence of actual rounding instructions, you round to the nearest 100th. So I look at my third digit, that tells me what to do with my second. 7 rounds up the 9, so this becomes 5.80. I put the 0 to say, yes, I considered this. And we are working with inches, so this is square inches. All right. We need to find the arc length of WX. WX is this segment right here, or this arc right there that measures 90 degrees. The arc length formula is 2 pi r times m over 360. I'm going to plug in what I know. 2 times pi times the radius. The radius is 14. I know that m is 90 over 360. I have 28 pi. I'm going to reduce 90 over 360 to 1/4. I can rewrite this as 28 pi over 4. 28 divided by 4 is an even number, 7. So my arc length is 7 pi, and this is measured in centimeters. I'm going to go to my calculator and say 7 times pi, and that gives me 21.9911. So my length of WX is actually approximately 29.11. And it is linear units, so it is just centimeters. We need to find the measure of angle LMP. LMP. So this is an inscribed angle. When I have the inscribed angle, I know that it is 1/2 its subtended arc. So the measure of angle LMP is 1/2 the measure of arc LP. Well, I know that arc LP has a measure of 36, so that means 36 times 1/2 is 18. The measure of angle LMP is 18 degrees. I need to figure out arc length, or excuse me, arc measure MN, the measure of this arc right here. And I can say that the measure of MPN is equal to 1/2 the measure of arc MN. I don't know what the measure of arc MN is, but I do know that the measure of angle MPN is 48. And to figure this out, I'm going to multiply both sides by 2. That 2 cancels out that 1/2. And I can say that the measure of arc MN is 96 degrees. Problem number 13, find the measure of angle X. So I've got the center of my circle is marked as D, and I've got an angle that subtends that diameter. It also subtends this arc, and this arc is no, it's not, it's 180 degrees. If that's 180 degrees, then I know that this right here is 90 degrees. So if I know that that's 90 degrees, and that says 5x plus 8, I'm going to say 5x plus 8 equals 90 degrees. I'm going to subtract x from both sides. 5x equals, well, not 72. Clearly that's 82. I'm going to divide both sides by 5. I'm going to go to my calculator because frankly I'm getting tired. 82 divided by 5 is 16.4. I'm finding x, I'm not finding an actual degree, so I don't need to put degrees there. Number 14, we are so in the home stretch. Okay, this is, oh my goodness, that says 5z. This is so funny. I did not read this earlier, and I thought that said 52. So I need to find this angle, the measure of angle FJH. And FJH is 5z degrees. I thought that was a 52 when I looked at this before. And there's also this angle right here that we're told about. And if you see, both of these angles share the same arc. They share the same arc. And if they share the same arc, that means that both of those angles are congruent to each other. So I'm going to say 5z equals 4z plus 9. I'm going to identify where I have the most z's and move everything else to that side. 4z, I'm going to subtract 4c from both sides, which gives me z equals 9. It doesn't ask me what z is. It wants to know what this angle is right here. So I'm going to say the measure of angle FJH equals 5 times, we determined that z was 9, so it is 45 degrees. And now we need to find the measure of all 4 angles. So I need the measure of angle R, the measure of angle S, the measure of angle T, and the measure of angle V. Okay, so one of the things that we learned was if we inscribe a quadrilateral into a circle, the opposite angles are supplementary. So I'm going to say angle R and angle T are opposite of each other. So I would say 7y plus 11y equals 180. This is the measure of angle R plus the measure of angle T are supplementary. So 7y plus 11y is 18y. And if 18y equals 180, that means that y equals 10. Great, that's good news. So the measure of angle R is going to be 70 degrees. The measure of angle S is going to be 10 times 8 plus 8 is going to give me 88 degrees. The measure of angle T is 11 times 10, which is also, we're going to say 180 minus 70. So any which way you slice it, that's 110 degrees. And angle V doesn't have anything labeled, but I know that the measure of angle S plus the measure of angle V equals 180. And I've determined that angle S is 88 degrees. So I'm going to set this up. I'm going to subtract 88 from both sides. So the measure of angle V is 92 degrees. All right, that's it, folks. If you have any questions, come see me during Lion Time or Mr. Lozar, or come visit us after school. We'd be happy to help. I hope you guys are having a great weekend. Thanks.